The universe is a vast, mysterious expanse that continues to expand, revealing astonishing phenomena that challenge our deepest assumptions about life and existence. For generations, humans have looked up at the night sky, pondering the stars and wondering what lies beyond. Since 1929, when astronomers first observed the redshift of distant galaxies, an indication that the universe itself is stretching outward, our understanding of the cosmos has grown dramatically. Over time, scientists have made profound discoveries that connect us, quite literally, to the stars. The atoms that make up our bones, muscles, and blood were forged in the nuclear furnaces of ancient stars that lived and died long before our solar system ever existed. When those stars exploded in powerful supernovae, they scattered the raw materials that would eventually form our planet, and us. By the late 1950s, the scientific community had developed a deeper appreciation of the night sky, not just as a thing of beauty, but as a display of immense energy, power, and complexity. Amid this grand celestial backdrop, many of us find ourselves reflecting on life's purpose, contemplating the mysteries of existence, and wondering how our lives fit into the immense canvas of the universe. And yet, despite the awe the cosmos inspires, daily life often keeps us grounded, focused on the immediate and the familiar. The drama unfolding in the skies above us can seem distant and irrelevant, until something extraordinary demands our attention and pulls our gaze upward. One such phenomenon is currently unfolding with Betelgeuse, one of the most well-known and mysterious stars in our night sky. Located in the constellation Orion, this massive red supergiant has fascinated skywatchers for centuries. But in recent years, it has started to behave in strange and unexpected ways, drawing increased attention from astronomers around the globe. Betelgeuse lies more than 640 light-years away from Earth, meaning that the light we see from it tonight actually left the star more than 6 centuries ago, long before the founding of the United States, and even before Columbus set sail for the New World. Even traveling at light speed, it would take over 640 years to reach Betelgeuse. And with today's space travel technology, that journey would take more than 12 million years, far longer than the entire history of human civilization. To give a sense of its size, if Betelgeuse were placed at the center of our solar system, its outer layers would extend beyond the orbit of Jupiter. This star is so enormous it makes our sun look like a marble next to a beach ball. Despite its brilliance and colossal scale, Betelgeuse is not the steady, unchanging point of light it may appear to be. It is a highly dynamic star in the late stages of its life, prone to intense fluctuations in brightness that reflect changes in its internal structure. It has long been classified as a pulsating red supergiant, meaning it expands and contracts in cycles that cause its light to brighten and fade over time. Some of these cycles last a few weeks, others span several years. One particularly significant dimming event occurred in early 2021, when Betelgeuse's brightness dropped to one of its lowest levels in recent memory. This sparked speculation in the media and scientific community that the star might be nearing the end of its life, a cosmic countdown perhaps to a supernova. These brightness fluctuations are tied to the star's surface temperature, which is around 3,500 Kelvin. That's cooler than the Sun's 5,500 Kelvin, and although Betelgeuse is much larger, it emits less energy per square foot of surface area. When the star expands, its outer layers cool and its brightness drops. When it contracts, those layers heat up again, and its light becomes more intense. What's especially concerning now is that Betelgeuse has shown signs of increased instability, which could be a signal that it's moving closer to the end of its life cycle. As stars like Betelgeuse age, they gradually run out of hydrogen fuel in their cores, the same fuel that has kept them shining for millions of years. As hydrogen fusion slows down, the star's outer layers expand while its core contracts, causing dramatic shifts in structure. This process leads to helium accumulating around the core, and eventually igniting in a more erratic type of nuclear reaction known as helium burning. During this phase, helium atoms fuse to create heavier elements like carbon and oxygen, releasing bursts of energy in the process. However, unlike the relatively steady fusion of hydrogen, helium fusion is unstable and releases energy in unpredictable surges. These irregular outbursts create turbulence within the star, disturbing its structure and generating powerful stellar winds. These winds, made of charged particles, carry away large amounts of matter from the star's outer layers. Over time, they reshape the star's envelope and affect how it evolves. Betelgeuse's surface is constantly in motion, almost as if the star is breathing. It expands and contracts like a giant glowing lung. Scientists compare this rhythmic motion to a cosmic heartbeat, though in this case, it's a heartbeat that tells us the star is nearing its final days. To study all of this, astronomers rely on sophisticated tools such as photometry, which measures changes in the star's brightness, and spectroscopy, which breaks down its light into its component colors to determine its temperature, chemical composition, and motion. Beyond these observational techniques, scientists also use complex computer models to simulate what's happening inside the star. These models incorporate everything from nuclear physics to fluid dynamics, allowing researchers to predict how stars like Betelgeuse evolve over time. One of the major internal processes they study is stellar convection, a phenomenon where hot gases from the core rise toward the surface, releasing energy and creating convection cells. These currents are a key driver behind the star's pulsations and brightness variations. The tug-of-war between gravity and radiation pressure also plays a central role in Betelgeuse's behavior. Gravity, of course, pulls the star's mass inward, while the radiation generated by nuclear fusion pushes outward. In a young star, these forces are balanced, but as Betelgeuse depletes its nuclear fuel, the balance becomes unstable. As radiation pressure weakens due to the declining fusion reactions, gravity gains the upper hand, causing the star to contract. This contraction raises the temperature and pressure in the core, reigniting fusion, this time with heavier elements. The renewed fusion causes the star to expand again, and the cycle repeats. These cycles can cause the star to flicker and fade from our perspective on Earth. During contraction phases, the surface grows hotter and the star appears brighter. During expansion, it cools and dims. These fluctuations, while visually striking, are more than just a curiosity. They give scientists critical clues about the inner workings of massive stars. Betelgeuse's enormous size and advanced evolutionary stage make its behavior particularly volatile. It has already passed the phase of stable hydrogen fusion, and now its core is surrounded by shells of helium, carbon, and even heavier elements. The fusion of these elements produces less energy and leads to more chaotic pressure changes, further contributing to the star's instability. As this fragile balance tips further, the risk of a core collapse grows. Eventually, when the fusion processes can no longer counteract gravity, Betelgeuse will explode in a supernova, a brilliant and violent end that will briefly outshine entire galaxies. For those of us who've spent decades watching the world change, from black and white TVs to space telescopes and Mars rovers, the ongoing story of Betelgeuse is a reminder of how much we've learned and how much there still is to discover. The universe remains as full of wonder as it was when we were kids staring up at the stars. Scientists continue to track Betelgeuse closely, hoping to catch a glimpse of what may be one of the most important stellar events of our lifetime. Its final chapter may still be years or even centuries away, but until then, Betelgeuse gives us a unique window into the life and death of a giant star. Thanks to relentless scientific research and cutting-edge technology, we are now able to witness and study events in the universe that were once beyond imagination. For older Americans who've seen man walk on the moon, who've lived through the birth of the internet, and who understand the value of time and perspective, Betelgeuse is more than just a star. It's a living story in the sky, unfolding before our very eyes, and reminding us of our place in a universe still full of mystery and awe.